Okay, my pre-calculus kids, we are starting Unit 8. We're actually starting a whole lot of units on trigonometry. For the rest of the year, we'll probably be talking about different trigonomic functions and how their graphs go and what good are they for and all that kind of great stuff. So we're starting in Section 8, Unit 8, with 4 sections dealing with angles and dealing with the measure of angles. It's kind of a little geometric. It's got a geometric flair to it. So the first section, 8.1, is on degree measurements. This is the unit circle that we're going to look at. And how do you measure angles with different degree measures? The second section is on radian measures. They're called radian measures. Kind of like, if you were to measure, I don't know, a piece of paper, and you pull out your ruler. On one side of the ruler, you've got inches, but on the other side of the ruler, you've got centimeters. And so you can measure your piece of paper either in inches or in centimeters, and it would still have the same length. The measurement, it's just a different type of unit. So Section 8.2 is a unit for measuring angles called radians, which most of trigonometry is using those radian measures. They kind of get away from this whole degree measurement thing that we're more comfortable with and know a little bit better. And then Section 8.3 is on measuring measuring arc lengths, kind of like the length of a pizza crust on a circle, and finding the area of a sector of a circle. That's 8.3. 8.4 is all the sine, cosine, tangent, right triangle trigonometry, solving right triangles, lots of word problems with how tall is the flagpole. You might remember that kind of stuff from geometry. So that's 8.4, and that's the whole unit before we go on to something else. But a lot of the topics we're going to be talking about for the next little bit are all based on trigonometry. So here we go. This one's called degree measures. Actually, let me show you what the packet looks like. It's called angles and degrees. This is what the note packet would look like. But before we get to this, I want to talk to you about these angles, so that when we come down here and try to draw some of the angles, it's going to make our life a little easier. So this is going to be our reference sheet for the unit circle. It's called a unit circle because this is the origin right here in the middle, 0, 0. And the radius of this circle has a radius of 1. So if I look at the coordinate for where this would be over here, this would be at 1, 0. This one would be at 0, 1. This one would be at negative 1, 0. This one would be at 0, negative 1. And then you come back and close it up again at 1, 0. So if I were looking at it coordinate-wise, the unit circle, it's got a radius of 1. That's where the unit thing comes from, a length of 1. But we're not there yet. We're only talking angles. So bear with me with angles. But keep that in mind, that's our deal. This is always this place over here, and I'm going to use a whole bunch of different colors to do this. This is always our starting place. When we go to draw an angle, you're going to start here. That's always going to be your starting spot. I'm going to move my paper up so that you only see this circle. You know that this is the degree measurement part, because when we get to the next section, it's the radian measurement part. But for here, we're going to start here. And so all of our angles have to start being drawn on this positive x-axis right here. And I have 2 choices. My choice number 1 is either I can go this way to draw my angle, right? I can go upward to draw it. And if that's the case, then it's considered a positive angle. Or I can start here on my starting line and go this way to draw my angle. And if I were to do that, that then becomes a negative angle. These positive and negatives are only about the direction. They're just telling you what direction you went. I guess you could kind of piece it like a number line. If you're looking at a number line, right, you go to the right when it's positive and you go to the left when it's negative. Same idea with this. We go up when it's positive and down when it's negative. So you can have positive angles and you can have negative angles. No matter which way you go, this is always going to be your first quadrant. Remember, it stops at the 90-degree mark there. This is always going to be your second quadrant. This is always going to be your third quadrant. And this guy here is always going to be your fourth quadrant. The quadrants do not change no matter which direction you make your angle. All right, so let's fill in some of these angle measurements and see where we get. Let's go with some of the big popular ones first, the ones that you'll know. This first guy here, if I haven't gone anywhere, he's 0 degrees. Now I'm going to do the positive ones first. Let me go up here to positive, positive, positive. This guy here is going to be, if I go up to the top here, it's like a right angle. This is 90 degrees. There's another popular one, right? If I keep going around to the next real popular one, that's this guy. He's 180 degrees. He's a straight line when you come around. Let's take it 90 further. That puts me down here. This one will be at 270 degrees. 80 plus 90 gives me 270. And if I close up my circle, now I'm back to 0, and this will be 360 degrees, a full circle, right? That's nothing new to us. All right, let me help you out with some of the more. Now, there are all sorts of different angle measurements in here. You could have a measurement of an angle that's smaller than these. I'm just giving you the popular ones that are around the unit circle. These are the ones that we're going to see most often. So, if I come up to this next line, this guy's really 30 degrees. The next one is 45 degrees. The next one is 60 degrees. Kind of makes sense if you look at it, right? This is a third of the way. Now I'm 2/3 of the way. And now I'm sorry, that didn't come out right. This is a third of the way up to 60 degrees. Then over here will be 2/3 of the way. And you're always trying to get to that 180 mark. So that's how the first quadrant goes. Here's how the second quadrant goes. This is 120 degrees. This one is 135 degrees. And this one is 150 degrees. You'll notice that it's 30 degrees plus 15 degrees plus 15 more plus 30. Pretty much that's where these are all coming from. All right, let's go 30 more. That puts this at 210. 15 from that is 225. 15 from that is 240. 30 from that is 270. We got that. We're going to keep going. I'm going another 30. Well, that puts me at 300. Then I'm going 15, 315. And then I'm going another 15, that's 330. And that closes up the circle at 360. And so those are all of your positive angles going around your circle. How does it work if you're negative? Well, things kind of flippy-floppy. You're going to notice some just some qualities that happen when you look at these positive and negative angles. But let me show you some. I'm still going to start here. Remember, you always have to start here. This is then 0 degrees. You're going in a negative direction. You haven't gone anywhere. So you're 0 degrees. Let's go down here and think about this guy. If I go from this marking spot here, the positive x-axis, and I stop here, I certainly haven't gone 270 degrees. I've really only gone 90 degrees, right? This is 90 degrees, but I went in a negative direction. I went down to get there. So if I start here, my starting place, stop here, I've only gone 90 degrees, but I went in a negative direction. So let's think of what these numbers would be, right? If this is 0, then this would be a negative 30. This would be, and I'm kind of watching what I'm doing in that first quadrant too. This would be a negative 45, and this guy would be a negative 60. So it's all exactly the same numbers. that are in this first quadrant, except they are negative because I went in a negative direction to get there. And so I can keep going around my circle, right? The next one I come to is 120, then 135, 150, and then 180. But these guys would be in a negative direction. So this would be negative 120, negative 135, negative 150. And guess what? 180 has a negative 180 as well. It's the same exact place, whether you go positive or negative to get there. All right, if I'm at 180, what comes next? Well, 210, 225, 240. But I went in a negative direction. So this is negative 210, negative 225, negative 240. And then if I come up here, he's going to be a negative 270. Now I'm here. I'm looking at my purple guys. I keep going. I'm 300, 315, 330. I'm going to do the same thing here. Negative 300. Negative 315, negative 330. Close up your circle, you're at negative 360. And so if I've gone in a negative direction, that's what my numbers would be. All right, so keep this handy because we're going to refer back to it as we get into the notes for this section. All right, here goes. You've got an angle. And you saw this back when you had geometry, that this point where the two rays come together is called the vertex of the angle. Now, the angle itself, we usually call, a lot of times you'll see it, it's like a fancy pants O. It's called theta. The angle they call it, they use this Greek letter called theta. And that's what they usually label the angle with, is that kind of a thing. So we talked about this just a little bit on the other sheet. If an angle's in standard position, it has to lay on this positive x-axis. That's called the initial side. This guy right here is called the initial side or ray of the angle. It has to always start there. That's the initial place that it starts. And then it could end anywhere you want. I'm going to make mine end over here. And this guy is called the terminal side because that's where it ends. So that the angle we're talking about that's made by generating this initial side and stopping at this terminal side is going to be this angle in here. Right? That would be the angle that I created. That would be my theta. So an angle in standard position has an initial side that has to be on the positive x-axis, and then the terminal side can stop anywhere. And the other thing too is the angle could be positive or it could be negative. So standard position, this part that I have in orange, that's what it takes. That orange thing is like the standard position. Make sure you have the initial side on the positive x-axis. We talked about this on our circle picture, that my quadrants still go. This is still 1, this is still 2, this is still 3, this is still 4. And if I'm looking at how the quadrants work, this guy's at 0 degrees, this guy's at 90 degrees, this guy's at 180, this one's at 270, and when I close up the circle again, he's at 360. So all of that is the same stuff that we just talked about on the bigger circle that we had. So draw some angles. Well, let's start with this middle guy, this 315. All right, you can cheat. Take your sheet. Right? If I'm 315 degrees, first of all, I'm positive. I have to start here on the positive x-axis, and I have to go up to get that angle. And I'm going to 315, so I'm going to stop right here. So I'm going to end in the fourth quadrant. Let's see if we can do it. 315. I have to start here, right? And I'm going to go all the way around and stop in the fourth quadrant. Now these are estimations. These are not looking for exact specific. But I need to see you ending in the right quadrant to be correct. This is what this angle would look like. It has to start in my standard position, positive x-axis. I have to go up to make the angle. And I'm going to stop in the fourth quadrant, and that's going to give me 315 degrees in a positive direction. All right, let's try 460. We'll keep with the positives for now, right? So if I'm at 460 degrees, whoa, Nelly, can I go 460 degrees? That's bigger than 360. My circle stops at 360. What the heck are they talking about, 460? Well, guess what? These angles can keep swirling around, swirling, 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 and swirling, and swirling. You could have an angle that's 2,000 degrees, but it just means that you swirled around lots of times. This one's 460, so if my circle were to stop at 360, how much further am I going past 360 if I want to get to 460? I have to go 100 degrees more. Well, where would 100 degrees fall? Looking at these numbers, 90, it has to fall over here in the second quadrant because that's where 100 degrees would be. So I am doing 460 degrees. In other words, I'm doing a whole circle, but I have to go 100 degrees more. I'm going to end up in the second quadrant. Here's what it looks like. Start here. Go all the way around. There's 360. But I have to go 100 more. That's going to stop me over here. See how it swirls around? Kind of cool. I usually put a directional arrow on that just to show that I went around that way. But you probably won't see that in the books. All right, negative 360. Well, let's do negative 150. Now the negative ones, again, we're referring back to our chart here, our circle. If I want to go negative, now I'm going this direction. Where is negative 150? Oh, over here in the third quadrant. I don't quite make it to this 180 straight across mark. So if I'm at negative 150, I have to start here, and I'm going to stop over here in the third quadrant. And I went down to make that angle. How about negative 360? I have to start here, go down. 360 degrees, though, makes the full circle. So I would stop here. Actually, stops where it starts, but it completes a full circle. Okay. Name some angles. Well, they want you to give an estimation. They're like, okay, well, what is this angle? Obviously, you can see it's a negative angle because you have it down here below the x-axis. So think about what that might be. Now, if you go to your circle, you can see it landed in the third quadrant, kind of down in this neighborhood. Well, in this neighborhood, that would be a negative 120 degrees or a positive 240 degrees. So let's see, we had to be negative. So this would be like a negative 120 degrees. Now let me go back to this circle because this was something I was thinking about, but I never really talked about it. What's something that you notice about these angles if you were to add them together? Now remember, the negative sign is just a directional thing. It is not, it's just telling that you went down to make the angle. But like if I look at this, 180 plus 180, 210 plus 150. If I take 225 and 135, if I take 240 and 120. And again, forget about the negative because the negative is just a directional thing. You'll notice that every single pair of these angles around the whole circle always add up to 360 degrees. So kind of a cool thing. If you can remember what the positive are, the negatives are just 360 minus whatever that number is. Okay. All right, so there's my name some angles. This guy would be a negative 120. What would it be if I went positive? That means I would be going this way around. Well, negative 120. If I take 120 from 360, I get 240. This would be 240 degrees in a positive direction. If they'd asked me that, but they didn't. The middle one, if this piece is 45, well, how big is this piece? They're not very specific on which angle they're asking you to find, but that's the one they were thinking of. Well, I know that together they make a straight line. And back from geometry and even from our circle, we know if we're at the straight line mark, we're at 180. If I take 180 and I take this chunk away of 45, then the angle I have is 180 minus 45, or 135. And so there's my angle there. This one, again, they didn't really tell me much information, but this one's 30 degrees. And they want to know, what's this guy? Well, if I look at them together, it's a whole quadrant. It's a whole quarter of my circle. So that would be 90 degrees together. If I've taken 30 from 90, I've got 60 left. However, is that a positive angle or a negative angle? And we say you're a negative angle. And there it is. That one's negative 60. Now these coterminal angles, we're going to come back to those. We're going to actually end with them because they're going to take us some practice to do. So we're going to come back to the coterminals and we're going to talk a little bit more about how they write these angles. Like you can have decimal places, but they have to be all funky about it and give it a whole new language. They can't just call it like 25.4 degrees. They got to have all this extra special stuff with it, a different way of writing decimal type forms. So they call it degree, minutes, seconds, and it's based like time. Now he gave a whole explanation using these little hashtag tick mark things on the video, but we're not going to get into great detail about it. All you need to know is if you have something that looks like this, 45 degrees, then the next number that you get is with minutes, and I'm going to write this out in words in just a second. They put a single little apostrophe next to that, and then they have seconds, 48 seconds. They put double apostrophe by that guy. So if I were to read this, this means 45 degrees, 30 minutes, and 48 seconds. That's what it means in real English. And so if I'm looking at that 5, doesn't look much like a 5, does it? Let me fix him. There we go. If I'm looking at 1 degree, he equals 60 minutes. Just like an hour. It's based like time. So an hour equals 60 minutes, which also is the same thing as if I were thinking of seconds, it would be 3,600 seconds. Just like our hour would be if I were to count the seconds. And 1 minute, well, we all know 1 minute equals 60 seconds. And so really what you need to know is what the symbols are that represent these things. When you see, if you've ever seen the surveyors on the side of the road or seen a blueprint of land, you'll see that in that blueprint of land, they always use this type of notation as to how big your property is and where the property line would be. They do not use decimal points. They totally have always used this type of measurement when they do blueprints and such, and surveys for roads. And you know, if you've ever seen those types of blueprints or see the guys on the side of the road with their little survey tripod thing, this is what they're measuring. They're doing measurements like this. And here's where it's important. You go to buy a house, you need to know exactly where your property line is and exactly how much land you own and where that might be, because you can't have your neighbor coming over and building a shed on your property. You need to know exactly where your property line is. So all of these are very important markings in the midst of it. So the last little bit here is converting between degrees, DMS, degree, minute, second, to decimals, and going the other way from decimals to degrees. So we're going to take a few here. We're going to do 48 degrees, 30 minutes. I'll just write these down for now, and then I'll show you in the calculator. 22 degrees, 45 minutes, 10 seconds. And then we're going to do another one, last one, 88 degrees, 26 minutes, 42 seconds. So there's our 3 examples for how to do these. Now, if you have the graphing calculator like I do, here's the deal. I do not have your little blue calculators at home, so I can't show you how to do this on the blue calculators. But when we're in class, I can definitely do that. So for now, here's what you've got. You're going to put in your degrees, 48 degrees. Now, where's the degree symbol, you say to me? And it's the second and then the apps button, because second apps gives you an angle thing. And see how the first thing to come up is your little degree circle. So you press enter, and that puts that circle right next to your 48, which is kind of good. All right, then we're going to put in the 30 minutes. So 30, put in 30. Go back to the angle menu, which is second apps. And now you see number 2, that has the little tick mark that you want. So go down to number 2, press enter. And darned if that doesn't look exactly like what I'm looking for, so press enter again. And it automatically tells you what you've got, 48.5 degrees. So this guy equals 48.5 degrees if I were to transfer that into a decimal form. Well, let's try the next one. The next one's 22. Go back to the menu. Number 1 is your degree sign. 45. Go back to your menu, and you'll see number 2. There's your minute sign. And then I've got 10. Now watch. If I go back to the menu, there's no double tick mark thing there. That's not cool. So for whatever reason on these calculators, the double tick mark is the plus sign down here, but it's green. So I'm gonna let me do the green. I don't know if it's gonna let me do this. Plus sign. No, it didn't get me out of there. Hold on. Escape this. Okay, 10. I'm back to my 10. Good. I need a green alpha and I need the plus sign. And that gives me the minute symbol that or the second symbol that I'm looking for. So here it is, 22.753 degrees. 22.753 degrees. All right, let's try one more. Last one, 88. Second apps, number 1. 26, second apps, number 2. All right, remember where I'm going to find my double tick mark, 42, alpha, plus sign, 88.445. All right, now how about if you wanted to go the other way? What if I gave you an angle measurement in decimal form and I wanted you to go the opposite way? What if I wanted you to take 12.45 degrees and tell me what that is, and negative 48.602, and tell me what that would be in degree minute second format? And so that's even easier yet. All you need to do, 12.45, go back to that angle menu, second apps, and you see the fourth one down, number 4, it says DMS. If I go down there and press enter, and enter one more time, it tells me specifically what it's going to be. So it automatically does the math out for me. Otherwise, you'd be dividing by 60 each time to figure out what the it gets complicated. But you've got calculators that do the work for you. So this one is 12 degrees, 27 minutes, no seconds. You don't necessarily need to say that, but that's what the calculator said, so we're going to say the same thing. When you go to put in the next one, you don't need the negative. The negative is just telling you direction, and so we know in the end our answer is going to be negative as well. But when I plug it in, I only need the 48.602. I'm going to go to the second apps menu, number 4. Hit enter one more time, and there it is. This one's kind of interesting because I've got a 0.2 at the end, but okay, that's all right. So it is 48 degrees. It is 36 minutes and 7.2 seconds. And so that's how you convert between the two things. All right, so it's all about the calculator. Again, if you have a blue calculator and you can't find the angle menu to be able to do these, just holla when we get to class and I can help you out with that. All right, let's try some examples real quick. And then we're going to go back and talk coterminal angles as we go here. So first one, say, you can see I picked number 4. First one, say, all right, draw the angle. in standard position, 440. Well, is it more than the circle or less than the circle? And this guy means it's 440 is more than 360. And so I'm going to have to go around the circle more than 360. Well, how much more? 440 minus 360 gives me 80. So I need to go 80 more when I draw this. Start in standard position. Start on the positive x-axis. I'm going all the way around once. That's 360. But I have to go 80 more. Now think about that. Am I going to hit this positive y-axis here if I go 80? And the answer is no. I'd have to go 90 to get there. So I'm going to stop over here in the first quadrant, and there's my angle. Now these take some practice, kids, to get used to how you're going to draw them. But that's your story for that guy. This one is a little more complicated. You're not going to see many problems like this in the scope of what we do, numbers 5 through 8. But because it's here, we'll talk about it. This is 60 degrees, kind of hard to see, but that's what it is. 60 degrees is that chunk. That means this piece is 60 degrees. Well, what does that mean this other piece is, right? If I'm 60 degrees for this much of it, that's a whole quarter of my circle, which is 90 degrees. 60 minus 90 means that this little piece here is 30 degrees. The angle they want me to find is a swirly-whirly guy. All right, so let's take it in pieces here. If I come around my circle and stop at that place, how far have I gone? My first swirl around, I've gone 360 degrees. I want a full circle. Well, am I going to go another full circle? So let's try it. Here I go. I'm going to swirl around, swirl around, swirl around, and stop again. So I went 2 full circles. I went another full circle. And then to get to the line where it stops, I have to go 30 more. So if I take all those numbers and add them up, I get 750 degrees. That's what my angle is. So those are a little bit trickier to try to find, but that's what your story is. All right. Next one I picked is number 9. Interesting, now they changed the directions. They said just state, got a hole punched out, but state the quadrant in which the terminal side of the angle lies. So you don't necessarily have to graph it, but guess what? For me, I need to see what it looks like for me to be able to graph, or to be able to figure out which quadrant you're going to lie in. All right, so if I'm thinking about this, 440, some of you can do this in your head. That's fine. The question just wants to know what quadrant it's going to be. If I am a negative angle, I'm going negative 90, negative 180, negative 270, negative 360. But how much further do I have to go? So this is the same idea as that one up above. If I take 446 and I take 360 from it, right, I have 6. I have 76, right? No, 86. 86, that's better. I have to go 86 more. So if I go 86 more, am I going to make it to the 90-degree mark? And the answer is no. So this guy is down here, real close to the negative y-axis. So my quadrant, what quadrant am I in? 1, 2, 3, and 4. Quadrant I'm in is 4th quadrant. There it is. So what quadrant does it lie in? If you can do that in your head, fine. Question wants to know what quadrant. There you go. The coterminals, again, we're going to come back to those in a couple minutes. Next, page 18 is also a coterminal. We're going to come back to that in just a minute. 23, now here's your calculator questions, right? How do you do these? Remember real quick? Real quick, right quick. I'm going to put it in. I have a negative. The negative is just telling me direction, so my answer is going to be negative. I'm putting in 28. By the way, if you put the negative in, it's not going to care. I'm putting in 28. I'm going to the angle menu, hitting number 1, degrees. 5, going to the angle menu, hitting number 2 for the single tick mark. 42, green alpha plus sign for my double tick mark. press enter. There you go, 28.095. Negative 28.095 degrees. All right, last one like this. Let's go the other way. If I do number 25, 142.125, and I go back to that angle menu, number 4, it'll automatically press enter twice. It'll automatically give me what those values are. So here's 25's answer, 142 degrees, 7 minutes, 30 seconds, converting back and forth. All right, real quick. You're stopping at 29. By the way, 28 and 29 are true-false questions. So you're only answering numbers 28 and 29. You don't have to do any of the rest of that skills review or application page. All right, so your problems are 1 through 29, but we still need to talk about coterminal angles. Are you ready? So, by the way, these coterminal guys, these come to some kids real quick, and other kids are totally bewildered by the concept of these coterminals. So we'll see which side of the fence you're on when you look at this. So what are coterminal angles? They are angles that share a terminal side. Angles that share a terminal side. This is one of those lessons also that I use colored pencils with, and a lot of times kids like the colored pencil idea in this. So if you have an extra color of some sort, you might want to grab it. So if I look at this first picture, I'm just going to guess how big this angle is. I'm going to just give it an estimation, a number of some sort. And I'm going to say that that angle, first of all, it's positive because I went in a positive direction to get there. I'm going to say it's 230 degrees. Remember, this would be 270. So somewhere, has to be somewhere between 180 and 270 degrees. We're going to go 230. Well, if that guy is 230, then how big is this guy? And so you think about it, well, together they make a full circle, right? Together they make 360. So I know that if I get this guy that is 230 degrees, and I subtract 360 minus 230, that gives me 130 degrees. That's how big this angle is that I have here in pink. He would be 130 degrees. However, I went in a negative direction to get it. They're coterminal angles. They share the same terminal side, just one is positive and one is negative. So when we made our first original picture, really what we were doing was a bunch of coterminal angles, because what happens when I add these guys together? Again, forget the directional part of the negative. You end up with 360. So these are all considered coterminal angles. It's just a matter of whether you're coming from a positive direction to get there or a negative direction to get there. Okay, the next one, say I have, let's flip it around. Say this angle here is 130 degrees. Right, so that's the original angle that they gave me, 130 degrees. I should have used a different color, but that's okay. Then I need, let's go in the negative direction. Whoop, that would be this guy, right? Always has to start in that standard place. I've gone 180, but I've gone past the 180. You know that 130 and my number has to add up to be 360. And so again, same kind of math we did over here. This would be a negative 230. Well, here's the issue. The issue is that you need one positive and one negative angle that are different than your original. This 130 guy, he was my original guy. I can't use him. I need somebody different to mark where that actually lands to be my positive angle. My negative angle's fine. 230, he's my negative guy. But I need a positive angle that's different than the original. And so here's what I've got to do. I always start here. Can't start anywhere else. Start here. I go around and I'm like, gee, I wish I could stop there, but I can't because it's the same as the original. I'm going to go all the way around the circle one more time. All the way around, but I have to stop here. And so then the question is, how far did you go? Well, I went a full circle. I went 360 degrees, but then I went this much more. Well, that's 130 more. And so my number is 490. That's my positive angle. That's different than the original angle. So I had to go around a full circle more in order to get there. Okay. Then they want all coterminal angles. Now we're not going to do a lot of this. I'm just going to show you what they're talking about. If I look at this angle here is going to be 30 degrees. They should have labeled these better, but they didn't. All right, so if I want all of the coterminal angles with this 30-degree angle, here's what it is. Let me tell you the answer first, and then I'll go back and explain it. It's going to be that angle, 30 degrees, plus any multiple of 360 degrees after it. And let me put the whole thing together, and then I can explain it, where n is an integer. In other words, like a whole number, positive or negative. All right, so here's what they're talking about. I have 30 degrees. In order to get to the next one, I've got to go a full circle around to get there. Or I could do 2 full circles to get to that stopping place. But I always have to go 30 degrees and then some other circle's worth past that. So 30 degrees, if I want to go around again, I'd be at 390. If I want to go around again, I'm going to be at 360 more. If I want to go around again, I'm going to be at 360 more. So it's some multiple of 360 where n is a whole number that is positive or negative. It's an integer. Again, we're not going to do a whole lot of these all ones, but just that's what they're talking about. All right, let's go back to the example practice problems. We're almost done. Oh man, I kind of almost did this one. Number 13. Find one positive and one negative coterminal angle to the given angle, which, by the way, some kids don't have to draw the angle to be able to do this. If you don't need to draw it, don't draw it. I draw it. Even after all these bazillions of years of teaching, I'm still one that draws the picture. I want to see the visual. So here's my 30 degrees right here. I need one positive and one negative. Well, in this case, if I look at the negative, he's going to go this way. All right, I've got to go down to get him. And he would be the rest of the circle. Together, these guys make a full circle. So if I take a full circle and I take away my 30-degree chunk, I'm at 330. But I went in a negative angle to get a negative direction to get there. So my negative guy is a negative 330. I should not put that in that location. That's going to get in the way of where we're going to go next. Hold on. I'll put it up here. Negative 330. All right. But I need a positive one, and the positive one has to be different than what the original is. So if I were to do the positive angle, this would be what I would want to do. But I can't stop there because that's 30 degrees and that's the original. So guess what I got to do? I got to go all the way around and stop there the next time. So how far did I go? I went a full circle. This time I went 360 and I went 30 more. That puts me at 390, and that's what my pink positive angle is. Now check out my numbers this time. I have a 390, which was my positive guy, and I have a negative 330, my negative guy. What happens if I add them together? Again, without the negative is just a directional thing. Let's see what happens with that. If I were to add them up, I get 330 plus 390, and that gives me 720. Well, that's a multiple of 360. these are always going to add up to be a multiple of 360, if not 360 itself. So on our circle that we made at the beginning, all of these coterminal angles, all of these sets always add up to be 360. But coterminal angles could add up to be a bigger number, but it has to be some multiple of 360. You can't come out with an answer of adding them up and getting 500. That doesn't work. That's not a multiple of 360. We're talking 360, 720. I think the next one's 1080, something like that. All right, so there's 13. We have one left. Number 18. And number 18 says, okay, find all the coterminal angles for negative 200. So let's, of course, for me, I need to draw the picture. Where's negative 200? Well, if I start here, there's negative 180. I need to go 20 more. Here I am over here. I am in the second quadrant. This is negative 200. All right. In order for me to get all of the coterminal angles, I have to go negative 200, but then it has to be any circle's worth beyond that. And so really, your answer is pretty simple. You don't have a whole lot of calculating to do. It's negative 200 degrees plus any circle beyond that. Any multiple of 360 beyond that. And we're going to just put the qualifier down for all three of these, where n is an integer. That goes for all three of those questions. You're going to put the plus 360n, but you need to make sure that you're saying that it's got to be some kind of a whole number. That, my friends, takes care of section 8.1. And we'll be back again to look at 8.2 with the whole new concept of radian measures and how do you convert between the two. Remember, like you convert between inches and centimeters? It's 2.54 centimeters equals an inch. There's the same kind of conversion type thing between degrees and radians, but that is for next time. So to keep you anticipating our next lesson, that's the anticipator. And I will see you. Shoot me an email if you've got questions.